Thanks. Welcome to our session on design, safety, and certification. We will have 5 presentations in this session block. And the first presentation will be by Christian Patrick from Airborne Wind Europe. Christian, go ahead.
Thanks, Roland. Yeah, so I will present something that we talked about already at this IEA Task 48 Work Package 3 meeting on, 2 days ago. So some of you have seen that, and yeah, for others it's hopefully new. We talk a little bit about this long-lasting discussion about our Airborne Wind Energy Systems obstacles, or UAS, some current activities, and then I give an update on the standardization roadmap, so what we are doing there. So this long discussion, are Airborne Wind Energy Systems obstacles like wind turbines, or are they UAS? And we discussed it for a long time, also at the West last year. This was already presented, but since we haven't talked about this at the AirWEC now, some slides also from 2023. Because we did a developer survey at that time, mainly led by Corey Hull from TwingTech, who's unfortunately not with TwingTech anymore, but he was very much behind this project, which was co-funded by the Swiss Civil Aviation Agency, and where basically all the major OEMs participated. And there was the question, what do you think a commercial airway should be classified? And then 20%, which is kind of 1 or 2 companies, said, we are an UAS. The same amount said we are an obstruction or obstacle. And the majority, or more than the other 2, said, okay, we are both. So this is also a little bit where we are still standing. But just to explain a little bit what the differences mean between obstacle and UAS. So for the pros, for the obstacle is that others have to avoid the Airborne Wind Energy Systems, and that gives us the freedom to just operate, and if anybody flies into our flight path, then it's the problem of the others, so to speak. We don't have this see and avoid requirement, which means that we can constantly focus on power generation, don't have to dive down to evade others. And we don't need a pilot, which is really a key thing, because on the UAS side, it's still not really foreseen to fly systems without pilots. There's this autonomous drone thing going on. So could you close the door, please? Thanks. But it's not really there yet. On the con side, it's that obstacle regulation is not really generalized across Europe. So every jurisdiction, and sometimes even within the country, have different approaches to that. So the lighting and marking can be different, for example. Then you need to partially restrict the airspace just to avoid that someone flies in there. And it doesn't really consider the ground risk. So if a kite drops down, then, it's an obstacle. There's really nothing to do with it, but the likelihood that this happening is probably higher than a wind turbine blade falling down. On the UAS side, you have the advantage that since 2019, there's European-wide regulation. So if one country gives you a permit to fly, if the conditions are similar, you can do that in another country. And we have now done this 2 times in the airborne wind sector with the cross-border permit from kite power from the Netherlands to Ireland. And now just 2 days ago from what we heard from Mozza Aero, from the Netherlands to Spain. And there's a defined methodology, a risk-based methodology to deal with ground and air risk, which is not yet Airborne Wind Energy specific, but that we could pretty well apply. But on the other side, as I said, you probably still need a pilot. Even if the pilot can go BV loss, you don't have to be on the site, but you have to somewhat look at it. And as Florian also explained 2 days ago, they must potentially have situational awareness. So really looking at the screen, and if something happens, then press a button for whatever reason. So this is potentially costly, even if you can overlook hundreds or thousands of different systems. But to be discussed, and autonomous operation as such is not really fully implemented in the drone business yet. And if you go the UAS route, depending on the kite size, at one point you may have to comply with very stringent certification criteria from the aviation sector, which is also then again costly. So coming back to the question, well, we are probably still kind of both, so depending on country, location, and system type. At the moment, we have this approach to say, let's try all these different routes and get experience with that. And then also the authorities get experience with that, and then hopefully something comes out which makes sense. Ideally, we would be really recognized as airborne wind energy systems, not reinventing the wheel on all the different regulations that there are, but using as much as possible, but still that they don't say, well, you are US or you are obstacle. Well, okay, it's an airborne wind energy system, so this and this and this applies. So that would be the ideal scenario. So as I said, from the, well, I haven't really said it yet, but basically the idea would be from the air risk perspective, we're an obstacle, others should avoid us. That would be ideal in this sense. But we have this advantage that potentially we could dive down, which would give us potentially a bit more sites to go to. But if we don't have to, it would even be better. So let's say we are an obstacle from the air risk perspective, and from the ground risk perspective, we could be considered in UAS in the sense that the methodology to reduce the risks and the mitigation measures are according to UAS. If we are only obstacle, we have to have other measures as well in place to control the ground risk if something happens. So that's status 2024, 2024. It may change. So that's really running, a moving target, or it's a work in progress. So just I don't go into the details in the survey. There were also then discussions of where do you see air risk mitigation. You see, for example, obstacle on charts for fully commercials on the white side. This is something that everybody thinks makes sense. On the ground risk mitigation, basically the majority, or there's a general feeling that we have to, should be approved to operate also over non-controlled area. So for the beginning not, but later on, ideally we can fly also in areas where you don't need a fence around or anything like that. The recommendations at the moment are we want specific airborne wind energy regulation, fair access to this airspace, so not saying, oh, can we please fly here, but that we have this spanning, what is called, overarching a priority for renewable energies to fly in the airspace, get our own symbol in the aeronautic maps, agree internationally on lighting and marking to not have the same issues as wind turbines have. Tethers shouldn't be marked because it doesn't make sense anyway, so it's difficult and you wouldn't see it. And other airspace users should avoid airborne wind energy sites. We could dive down, but ideally we don't have to. And if there are cooperative airspace methodologies like U-Space, I don't explain this now, but that's the cooperation of all the airspace users, then we would be happy to deal with that as well. So ideally maybe using transponders for AOS, but to be discussed. Current and planned activities, I have to, how many minutes do we have, sir?
15, not 12.
So another 5 or so.
Yeah.
I discussed this more lengthy in the other talk. SkySails is now going the obstacle approach. They are very much advanced, or they got basically the mandate from the German Ministry of Transportation to say what would it mean if you are an obstacle. So they have to go through a stakeholder consultation that is running right now. And they say, okay, we mark the kites, red and white, synchronized lighting, off-ground station and pod. Getting into the aeronautical charts, we are not a cooperative obstacle, no radar transponder because that's not foreseen for obstacles, no tether marking, and maybe we need danger area. So this stakeholder consultation takes place now. Then this summer we will discuss that also among us together with experts, and then maybe towards the end of the year we come to some kind of more specific way of, okay, obstacle or not. Let's see where this ends up. But this is an interesting process because it's may lead to some more decisions. It's interesting here to note that the competent authority, Ministry for Transportation, they deal with the obstacle approach, but if you go the drone approach, like Twintech, but also Kitecraft, they talk to the Luftfahrtbundesamt, which is another agency, and they say, okay, you are probably a drone, and if you don't want to be a drone, you need an exemption in the drone regulation, and so it's so also the authorities are not really clear. Not sure how much they communicate with each other. So we have now the second version, the middle one here of this our white paper, where there will be then, depending on how much progress we make, another report or white paper version 3 or whatever we call it, then maybe already another IEA logo. Let's see. Sector making progress. I mentioned already the cross-border flights permits. We have now also beyond visual line of sight permit from Kite Power just in March. We have the validated power curve. That's, well, just a big milestone, let's say. But Enerkite also achieved the permits for a new test site in Brandenburg, close to Berlin. Just the last piece is missing, but basically it's there. And yeah, we are in the Norwegian regulation. They now recognize and really specifically talk about desert drones, which now takes a little bit too long to go through that. But it's some positives and some not so clear parts, but at least they start to recognize that they should deal with us. So that's good. Then other activities that we are doing, just last minute with Roland's help, starting to map all the sites with all these different topics here that you see. Most of our members have already filled this out, so it's really, we're getting a nice database here that we can also do analysis over then, so you can ask then at one point, okay, who takes the obstacle approach, and then you have different colors. So we can do a lot of stuff with these kind of things and attach pictures so that also the authorities can see, okay, this is what's happening, and you have some more cross references and so on. So you can, and when you click on this, you can scroll down and see all this information and make different filters and so on. Roland also included the old sites from Makani, and so we built this up now, and hopefully we will have more sites in future. So just a few words on the standardization roadmap, which is not really airspace so much, because we have to do it there as well, but basically, as you know, we have the wind energy sector regulation and all the standards that are applying there, but then we have to potentially, or if we are in UAS, also deal with all the aeronautical regulation. Now focusing here on the left side, the power plant and the part of the producing energy. The key standard there is the IEC 61400 for wind turbines. And just on Tuesday, I got a slot in the technical committee 88 meeting of this IEC standard. So this is the ones that regularly meet and discuss how do they further improve the standard. So I presented Airborne Wind Energy. They were quite positive about that. There's also support already from some countries that gave us good hints prior to that call. So the idea would be to have an overview standard for airborne wind energy. At that meeting, I proposed 61400-70, but right afterwards, I thought we need the 8 for the figures of 8 or 0, flying in 0. So I will propose now 80, because it's not, it's still open, free. So let's see. But that would basically be the overview standard, and then describing the system in general, and then we would make references to whatever is there. For example, then the power curve is -12. We would say, we had this nice talk yesterday from SkySails. We comply with all that. Certain parts are not really applicable. So this is where we need then, here on the right side, a specific airborne wind energy section or provision that in the case of an airborne wind energy system, you measure not at hub height, but at 200 meters, for example, and things like that. So
we also need to come to an end.
Yeah, it's the last slide. So this is now what we have, well, and there's also a report which also helps here from a study paper from Oral Catapult, which also proposed this approach. So now we have to get into that. We need support from countries. We start with the IEA Wind Task 48 countries to support us. And I guess we will get, I think you need 5 to say, okay, we start this new series. We need to identify a project manager, a convener, how it's called, and then start these meetings. And we would start with the power curve because that's what we need anyways, and it seems to be quite straightforward. Then we have already something there. Yeah, and with that, thank you very much.
Are there any questions? Very clear story. Well, then thank you again for this talk.
Welcome.
And we head over to the next talk by Edward